Hey, Fusion 360 users, if you do not have your own CNC machine, today we're going to show you how to take this Fusion 360 design, add CAM operations, then actually make it using a CNC machine in the cloud and get it shipped to your doorstep. Welcome to this quick introduction to SendItCNC. This is for everybody in the Fusion 360 community who doesn't have their own CNC machine but would like to use one. We're going to go through how to get your Fusion design cut on demand from a real piece of raw aluminum bar stock using your CAM program and a CNC machine in the cloud. We think this is pretty cool because now anyone in the Fusion 360 community can make parts on a real industrial CNC milling machine. Today, we'll get the downloads you need to use SendItCNC, add basic CAM operations to this design, and then submit the job to SendItCNC.com. If you're new to CAM and CNC machining, it will be helpful to look at the great CAM learning materials available to the Fusion 360 community. We're going to assume that everyone watching is comfortable with the concepts and terminology used in CAM and CNC machining. First, let's look at the design we'll be working with today. As you can see, it's just a small box. This is designed to be easy to machine, so we'll call it the EasyBox. Let's look at the parameters. This little box is designed to be made out of a piece of 1" by 2" aluminum bar, 3 inches long. Looking closely, you can see that we've left a small allowance of 15 thousandths of an inch, or 0.015 inches, on the top, sides, and ends, so that we can cut a nice finish there. This example is super simple, just to illustrate the basic concepts of using a CNC milling machine in the cloud to make a real part. Let's go to SendItCNC.com to get started. To the downloads page. There's a lot of material, but the easy way is just to hit Get It All. And let's see what we get. For this video, we only need the 3 files in the Quick Intro Kit folder. In a subsequent video, we'll do a full install of the CAM tool libraries, templates, examples, and so on. But for now, we just need the Quick Intro Kit. Okay, I've created a new project called SendItCNC. Let's upload the 2 Fusion design files from the Quick Intro Kit folder. Soon, we're going to go over to the manufacturer workspace to specify how the CNC mill should cut this part. But first, we're going to get a predefined CAM setup and model of the aluminum bar stock. Let's open the file called Vice, Stock, and CAM Setups, and go over to the Design workspace if you're not already there. You can see the Vice and the piece of bar stock. We're going to make the EasyBox out of standard 6061 aluminum. This is probably the most widely used type of aluminum in CNC machining, and it's relatively inexpensive and forgiving to machine. There are lots of sizes available for our SendItCNC mill. As we said, for this project, we need to start with a 1" thick by 2 inches wide piece of aluminum bar cut to a length of 3 inches. If you explore the SendItCNC website, you'll discover the range of bar stock sizes available, presently in lengths up to 7 inches. In the design, we'll adjust the parameters to get the model representing the stock to be the size we want. Now, let's get our EasyBox design. Make sure to activate the model component and just use Insert into current design, and it's there. Fusion makes it easy to move the design into place with the move command. First, a point-to-point move to get the top center of our design to the top center of the stock. Then, a translation move to get the EasyBox design just below the top of the stock. Remember from the EasyBox design that the top stock allowance was 0.015 inches, or 15 thou. Let's save our file, giving it a new name, EasyBox First Op. That's it. We're done in the design workspace. Let's go CAM it. Over to the manufacturer workspace to get down to business with milling this part. For simplicity, just import the SendItCNC defaults for CAM. Don't worry, because you can always go back to the built-in defaults, or if you have your own defaults, remember to save them first. Let's look at Setup 1. You can see the machine selected is the SendItCNC small mill for aluminum. The WCS is defined, our model is specified, and the work holding fixture is specified. Our stock is also defined. Fusion says the stock width is 3.05 inches, and that extra 0.05 is the little bit extra that might be there because of the tolerance for the saw cut when the stock is prepared. There are a couple of operations already provided for us. Let's look at them. First, there's a probing operation to precisely locate the workpiece. More on that in subsequent videos. Let's take the vise out of view and look closely at the box. Now, we do an adaptive clearing operation, which is our go-to toolpath for roughing out a part like this. Generally, of course, we do roughing operations to remove the majority of the material, followed by finishing operations to put a nicer finish on the part. The approach used by 3D Adaptive is referred to by a few different names like high-speed machining or constant engagement cutting, and is generally our preferred roughing strategy. The cutter is a 1/2 inch end mill with a .03 corner radius, so it doesn't have the fragile fine points that a flat end mill does. Corner radius cutters are our preferred roughing tools, but they're also useful for finishing cuts. There's quite a few toolpath parameters, and the Fusion defaults are generally a great start. Our CAM defaults file, which we previously loaded, has a few refinements for convenience when using SendItCNC. We've selected shaft and holder, so you'll get more collisions diagnosed before getting to simulation. And we've added smoothing. We've reduced the stock to leave for finish cuts to 10 thou from 20 thou. In this particular predefined toolpath that came with the setup, rest machining is set to from setup stock, since it's the first cutting toolpath in the setup. Also, and importantly, in the heights tab, we're going to have the cutter reach down 50 thou deeper than the bottom of the model. This is because the cutter has a radius on the bottom corner. Let's see what this looks like in the Fusion CAM simulator. Simulation is always your friend, but with SendItCNC, this is particularly true. It lets you see what the CNC machine in the cloud is going to do and what the result will look like. We're going to look at the comparison view, so we expect this to remain all blue after the roughing step. Looks like we're getting somewhere. As we're doing CAM programming, we'll do a lot of iterations of adding or changing our machining operations and then simulating the result. Let's use a 2D contour operation to finish the outside of the workpiece. We're just using the same 1/2 inch cutter. With the 3D operation we just did, the CAM system just figured most things out. But we're going to use a 2D operation here, and with 2D operations, you have to explicitly tell the CAM system where to machine, which contours, and what depth. We specify the appropriate contour and remember to add extra depth beyond the model bottom because of the corner radius on the cutter. Simulate and fast forward directly to the end. Green means that the finished cut was as intended, so it looks good. Now, let's finish the horizontal areas. First, what's the radius of the bottom corner between the walls and the floor? Inspect, measure, and we see that it's 0.09 inches. It turns out that we have an end mill with exactly that corner radius. We did say that the EasyBox was designed to be easy for us to machine. We'll do a 3D horizontal toolpath. Go to the tool library to select tool 93, which has that 0.09 inch corner radius, and the default should be fine. In this case, the horizontal toolpath will have the effect of finishing the inside walls reasonably, as well as the floor of the box, although a 2D contour for the inside walls would perhaps be preferred. Let's add one last operation for the chamfers. I'm going to use a 2D chamfer operation, select the chamfer mill, tool number 31, and select the top contours of the chamfers. Simulate. In comparison view, areas finished within tolerance are shown in green, and it looks beautiful. Okay, we need to flip the part over and finish the bottom, and we'll do that in the next video. But right now we're going to submit what we have here to SendItCNC, and we will receive an aluminum part that looks like what we're seeing here in the simulation, and the job could be submitted, cut, and shipped all in the same day. Let's take a look at Fusion 360's estimate for the machining time. Just under 5 minutes. We'll save our file, and we also need to export it to our downloads folder so that we can attach it to the SendItCNC job. Quick tip here, if you want the export to go fast, you can break the link to the EasyBox design like we're doing here. Now we go to the SendItCNC website to actually get this beauty made. Under Make a Part, select Submit a Job. You'll create a user ID if you don't already have one, and log in. This job is EasyBox First Stop. Under Stock, we'll specify 1 inch thick aluminum bar, 2 inches wide, cut to a length of 3 inches. There's presently only one choice for a machine, and recall that we need 5 minutes of machine time. Setup will be a 4.5-inch wide milling vise with the go-to jaws for first operations, the 0.125-inch multi-step jaws. We only use tools from the standard milling library, so no optional tools. We attach the file that we just exported from Fusion 360. SendItCNC tells us that there's machine time available and provides an instant cost estimate. So hit checkout. For the demo, I'll use a special discount code which should not work outside the demo, but if it does, then that's a gift from SendItCNC to you. Continue to shipping and complete the order. I'm through the checkout and back to job status. Okay, payment method verified, waiting for validation, and then validation begins. At this stage, the SendItCNC system is checking that the stock, setup, and tools match what's used in the model, that there's no collisions, and that cutting loads are within acceptable limits. If you edited the tool definitions or changed the setup models like the size or shape of the vise, this is where it will either be automatically corrected if possible, or the job will get an error diagnostic. Next, the part will be made and shipped. SendItCNC is the democratization of manufacturing. Check out our next video where we finish up the EasyBox.